Hello everybody! 1 year ago, I made a video about one of my favorite pieces of equipment in my rack, the Leitch CSD-5300 clock system driver. If you do not know what this is, if you haven't watched the original video, I really recommend it to you. I think it was one of my better YouTube videos, and it provides a lot of information, history, and demonstration. You can find it in my Best Of playlist called Flo's Picks on the YouTube channel. But in short, this piece of equipment is what's commonly called a master clock or a master clock driver. Its purpose is to keep the time, and in the case of this unit, also the date, and to output the same as time code. And time code is very common in the broadcast industry. There's lots of equipment, playback and recording systems, and lots of other pieces of equipment, computers, special purpose computers, and the like that all rely on time code. And there's very simple devices too, ordinary clocks that can get their time using a time code signal. The purpose being that everything in your radio or television facility that displays or otherwise uses the current time of day, everything is synchronized to the time exactly. And master clocks are very common. This is one of many devices that exist, but the Leitch CSD-5300 is very cool because in addition to being a simple master clock that can drive slave devices like clocks and computers and the like that take time code, it also has a built-in Bell 103 compatible 300 baud modem. You can hook this up to a telephone line and you can call a Leitch CSD-5300 either using another 5300 or using a computer with a modem or a terminal connected to a modem. And you can send commands to it to give you the time and date over the telephone line as human readable ASCII characters. And the other CSD-5300s that can call this unit, they can automatically synchronize themselves from the unit that they're calling. This is the only master clock of its type that was ever made. It was designed and manufactured by Leitch Video, a Canadian company who sadly no longer exists. And the cool thing is that it was developed in the 1980s in partnership with the Canadian government. The National Research Council of Canada in the 1980s was devising a hypothetical network of clocks that were connected to the telephone line and could keep each other synchronized via telephone calls, and that anybody could call or use a piece of equipment to call their local CSD-5300 to get the time and date. It was a nationwide hierarchical network of these clock system drivers, and that's what the Canadian government envisioned. And so they partnered with Leitch Video to develop a master clock with a built-in modem that could realize this. Now, unfortunately, this nationwide network of CSD-5300s never came to light. The user base just probably wasn't there, and this nationwide network never really developed. I think the Canadian government's plan was for every major city in Canada to have this unit. They all synchronized themselves back to the master unit at the National Research Council of Canada, and then every radio or TV station could call their local unit in their city to get the time and date. But this network never materialized. As far as my research can tell, the only publicly advertised Leitch CSD-5300s that were ever put into service with publicly advertised numbers that you could call were in Ottawa and in Toronto, both of them run by the National Research Council of Canada themselves. And today the Toronto number is no longer in service. However, the Ottawa number is still in service, so you can call the NRC's facility in Ottawa and a Leitch CSD-5300 will answer. And if you have a CSD-5300, you can call the NRC's number to synchronize your unit with this unit. Now, the really cool thing that I've done with this CSD-5300 is I believe that I have the only unit in the world besides the units operated by the NRC on a publicly advertised phone number that anybody can call. In the first video I made of this unit, I made the announcement that I have this connected to a telephone line, and I publicly announced two phone numbers, one in the United States and one based in Canada, that anybody could call as much as they wanted, anytime they wanted, for any reason. And I am now running, I still believe, the only unit in the world besides the NRC's own units that are publicly accessible via the telephone network. So it's been really, really fun. It's been a really worthwhile endeavor. And in this video, I'm going to provide a 1-year update on how this unit's been doing, what all has transpired since I made publicly available the phone numbers that you can call this thing on. And also, I want to talk more about slave devices that you can connect to one of these through its timecode output, specifically Leitch's own slave clocks that they made. I talked about the Leitch clocks a little bit in the original video. I would like to talk about them more. Another broadcaster recently gave us 8 Leitch clocks. A few of them needed some minor repairs, and so I would like to take the opportunity to show some problems that I've personally seen arise in these Leitch clocks and what you can do to repair them, because I don't think there's any YouTube video on how to maintain and repair Leitch timecode clocks, so I'm going to do that in this video too. So, starting with what all has gone down since I did something crazy and announced 2 phone numbers out on the internet that anybody would call. I said in that original video, I said call it whenever you want, as much as you want, you can't bother me. And that was true, and that's still true. And I am really happy to announce that in the past year, this thing has received 120 phone calls as of the taping of this YouTube video. And that excludes calls made by myself. And that is just great. I am so happy that so many people were interested enough to give this thing a call. To date, I have not received any calls from other CSD-5300s, although I will say, I said in the original video that this is one of 2 units that we have, we being the TV station. We have a unit in use at the TV station. It drives a couple of slave clocks, and this was our spare unit that turned out to not work. The power supply had failed because the capacitors went bad. And so I was allowed to take this unit home, recap the power supply, got it working, and I've kind of been its steward ever since. It's available to the TV station if our unit ever fails, but until then, it's here with me in my rack, connected to my telephone line, and I love it. Well, ever since I learned how to use these, I have always wanted to connect our unit at the TV station to a telephone line and program it to call my unit. And a few months ago, I finally did that. Our unit at the TV station is now connected to a telephone line, and it's programmed to call my unit for the time. And that only happens basically whenever the power goes out, and if the power goes out for long enough that the UPS it's connected to doesn't stay running long enough, then once power is restored, it won't automatically call this unit because I don't want it making unexpected calls on one of our telephone lines, but I can command it to manually call my unit and retrieve the time and date, and it works fantastic, and it's awesome. So yeah, this unit now receives calls from the TV station's unit whenever it needs it, but otherwise I've never received any calls from another CSD-5300. I hope maybe someday a hobbyist like me, or maybe even a professional who looks after one in a professional environment will see one of my videos and maybe indulge and call my unit with their unit. That would be pretty cool. But I've received 120 calls from other devices. Many people have called using modems connected to their computer, and I actually, my VoIP provider gives me the option of recording calls, and so I have it set to record only incoming calls, because I'm never first of all, I'm almost never present when this thing receives a call, but on the off chance I am present, I have the speaker turned down so that calls in the middle of the night won't disturb me. So I actually have incoming calls recorded from my VoIP provider so that I can go back, see if any calls have come in and see what they've done. And it's been really fun to see what people are calling this thing with. A lot of people have called with modems, and you can hear them typing in commands. A lot of people type in help and then return so that it prints out the big help list, and you can obviously tell from the sound that the modem makes when it's doing that. A lot of people have called just on a regular telephone just to listen to the thing. And then besides that, I've had people call in with things that are not modems, I guess just to see what would happen if they did. And that's been really amusing for me to listen to. I've had people, for example, call in with fax machines. I once had a person call in with one of those teletype machines that the hard of hearing can sometimes use on telephone lines. And that didn't do anything either, but it was cute to witness nonetheless. I've had people call and punch in DTMF tones to see if the unit would respond that way. And yeah, that's one occasion where someone had some fun with it. And then one time I got a call from someone who I think was just lost. I don't know, maybe a girlfriend or an ex-girlfriend gave them a bad phone number or something. They seemed to call and be lost and be quite upset when they were greeted with a carrier tone.
Really? Oh, off, yes. I just don't.
Yeah, that was kind of amusing when I found that. Whenever I get an interesting call recorded, I'll share it on my Mastodon whenever I get them. But yeah, it has been so great to see that so many people were interested to call this thing. A couple of people have told me they've actually been appreciative that this exists because there are almost no Bell 103 compatible modems publicly advertised to call. And sometimes people want to test a Bell 103 modem without calling a modern modem and hoping that it eventually falls back to 300 baud. So people have been calling this thing simply to test modems, and that's great. I'm happy for all of it. I'm happy for the people who call and try to see what they can break by dialing DTMF tones or whatever. I'm happy for the people who call with their modems, and I'm happy with people who call just to listen to the carrier tone, just to prove that I'm not lying and the thing actually works. I am so glad. 120 calls, and I hope they keep going. And I hope someday somebody, some hobbyist or somebody grabs a CSD-5300, and I would be very honored if they programmed it to call my unit to retrieve the date and time. I will say, as a bit of a reminder, that when you call this unit and retrieve the time, this unit serves the time in Atlantic time. So you'll have to do the conversion there. If you have a CSD-5300 and you call my unit, you'll have to set a phone offset in it so that it converts the time to your time zone and displays the time correctly. So yeah, that's how it's been going. It's been very reliable. I received a lot of feedback from people who have called. I think only one or two occasions somebody spoke to me and said that they had issues dialing in, like it wouldn't hear their commands. But in at least one of those cases, the issue was actually on their end. Like they needed to turn off echo suppressors on their VoIP adapter or whatever. So sometimes you might be able to do that. And a shortcoming that I had made in the original video, because I don't think I realized it until the video was already posted, was that when you call this thing, if you call it with a computer and you want to type commands into it, you have to hit return first. It won't listen to your commands until you hit return first. So once you are connected to this thing, if you want to type the help command, you have to hit return, then type help, then hit return again. And after that, it'll listen to your commands. You won't have to type an extraneous return again. Unfortunately, I have gotten a few calls from people who did not do that, and they typed a command and hit return, and the unit didn't do anything. It needs that first return for some reason. So I regret that I didn't say that in the first video, but I'm doing it now. So yeah, that's the updates with all the telephone related activities with this thing. And I will divulge the phone numbers one more time. So I've got an American number and a Canadian number. The American number is 989-CSD-TIME. That's 989-273-8463. That number is based in the state of Michigan in the United States. If you're in Canada, the phone number is 506-408-0067, and that's based here in New Brunswick in Canada. So those are the phone numbers. If you haven't had the chance, if you happen to be someone who tinkers with modems or other telephony stuff, please feel free to give this thing a call. You can't disturb me. It costs me very little money. It's like 1/10 of a cent per minute. Each phone number costs me, I think, $1 or $2 a month, and then calls themselves are 1/10 of a cent a minute. And I'm so happy to expend that very little amount of money to have this thing on the telephone network, and to let people go hog wild with it if they want to. So that's that. Another thing that's been going on. After I posted, this is really cool, after I posted the first video of this thing, I received an email from an engineer at the British Broadcasting Corporation, the BBC. This person, who had been at the BBC for, I believe it was 50 years that they had been employed there, he looked after, as part of his job, a Leitch CSD-5300. They use them across the pond too. And he gave me a really cool tidbit, which is that the oscillators on these, so the the electronic mechanism that generates the clock pulses, that needs to be a very exact frequency for these things to keep time, it can be adjusted very easily. I knew it could be adjusted, but I didn't know how easy it was. And he told me a really simple way to, it takes time, you have to do it over several weeks or months, but a way to tune the oscillator on these to be very, very accurate. And so using his method, I did that with this. And I've gotten the oscillator in this thing very, very accurate. I think the longest I've been able to go between power outages here was like 6 months. And in 6 months, this thing only deviated by a second from the actual time, which is great. Actually, it was actually quite a bit less than a second, if I remember right, but it's very accurate. And I've been tuning the one at the TV station too. That's going a lot slower because I don't remember to check it very often. But yeah, both of these units, the one here and the one at the TV station, they had drifted quite a bit over 35 years. The one at the TV station was gaining, I think, a second or almost 2 seconds per month. And this one was too. And now I'm down to like maybe a little over a second in a year, which is great. So what I'd like to do right now is I will show you how the oscillator in one of these is tuned, and an easy, if you don't have lab equipment, an easy way to tune it yourself. This is the oscillator board of the CSD-5300, and you can see there are 2 pins and a trimmer on the board. The pins are labeled control voltage and ground, and the trimmer is labeled frequency. So what you want to do is you want to grab a multimeter, set it to DC volts, and connect it to the 2 pins. And the multimeter gives you a voltage. You can see my unit is reading 2.4 volts. That is the voltage that of something, whatever drives the oscillator. And from the factory, Leitch would have tuned this oscillator to be around 2.5 volts. And of course, my unit ran fast when I received it, so I had to adjust it down. So that frequency trimmer adjusts the frequency of the oscillator, and it also adjusts that control voltage. So you can use that control voltage as an indicator of how far you're adjusting the oscillator. So in my instance, when I received this unit, I think it was reading around 2.44, 2.45 volts. And so I've adjusted it down by 0.04 of a volt. And that's what you're going to be doing. You're going to be adjusting this thing by a matter of hundredths of a volt. And my recommendation is, if you know your unit's way off, like if it's fast or slow by a second or more a month, it's probably safe to adjust it by, say, 0.05 of a volt. Turning the trimmer counterclockwise will increase the frequency and the voltage. Turning it counterclockwise will decrease the frequency and voltage. So my unit was running fast, so I decreased the frequency by turning the trimmer counterclockwise. So turn it by, depending on how comfortable you are. Maybe it's only 1 or 2 hundredths of a volt, maybe it's more. But turn it, and then on your phone or your computer, go to a website that gives you an accurate time of day. In the United States, you may use time.gov. Here in Canada, I may use the National Research Council of Canada's website, and they will give you a very accurate, kept to time by special atomic clocks, and they'll give you a very accurate time of day. They measure the latency between your computer or your phone and their server, so they know that the time being displayed on your phone or your computer is accurate down to a tiny fraction of a second. So go to your website of choice where you can see the accurate time of day, and then adjust your unit so that it's displaying the time as exact to the website you're looking at as possible. And you'll do that using the millisecond offset. The millisecond offset is a nice feature of these where you can tell it to adjust the time by however many milliseconds, from 1 up to, I believe, 1,000. So 1 second. And so you can make the unit adjust itself by very tiny amounts, and then you can visually look at the clock and compare it to the time being displayed on your phone or computer to know when your unit is exactly synced up with it. You can keep putting in offsets and then looking and putting in offsets again, going smaller and smaller and smaller offsets until it's as visually correct as you care to make it. And then leave it for a month, maybe longer than a month, and then come back to it, load up your website of choice again, and see how fast or slow your unit is compared to the website. And then, if your unit is fast or slow, you know to adjust the oscillator down or up. And you might do that by 1 or 2 hundredths of a volt or more. So that is how you adjust one of these. I've done it to this unit over the course of the past year, and my unit is very, very accurate now. So that is how you can tune these things to keep time as accurately as possible. Once you do that, I guarantee it'll be the most accurate clock in your house, aside from your phone or computer that syncs itself to the internet. Let's talk about clocks, probably the most common type of slave device that you'll see connected to a master clock driver. These are 2 slave clocks made by Leitch. Leitch was one of many companies who made slave clocks, and they're all compatible. Time code does not change from manufacturer to manufacturer. At the TV station, we have a slave clock made by Leitch and a slave clock made by Evertz hooked up to our CSD-5300. So these 2 clocks, you can probably see, they look darn near identical. Maybe some slight cosmetic differences between them, and they were only made a couple of years apart from each other. But when I apply power to them, there's no power applied yet, but they are both hooked up to time code coming off the CSD-5300. When I apply power to these clocks, they are going to set themselves according to the time code, and they're going to do so in very different ways. So let's see what that looks like. I've actually got to reach in front of you, so pardon me. And there you go. The clock on the right has set itself, and I can verify that it has set itself correctly. It is showing the exact time as indicated by the display on the CSD-5300. And then the clock on the left, it's kind of doing an Alice in Wonderland round and round kind of deal. So for some reason, Leitch offered side by side clocks with 2 very different types of mechanisms. The clock on the left has a single stepper motor that drives a very traditional clock movement like what you would see on a standard 120 volt AC powered clock. The clock on the right has a much more advanced movement that has 3 stepper motors, 1 for each hand, so it's able to move the hands individually. So the clock on the right was able to set itself very quickly. The clock on the left is actually about to be done. You can see it just slowed down, but it has to wind round and round and round. And it was just by luck that that it was close to the actual time. If it had been like 6 hours off, we'd be sitting here waiting 20 or 30 minutes. for it to set itself. Now I'm crossing my fingers, hoping that it actually will show the time accurately. Why I have to cross my fingers, I will explain very shortly. And it's gonna start going at the 6 or 7 second mark. Okay, that is not quite right. It is a few seconds off. So what I'd like to do is explain the different issues that you'll encounter with these Leitch clocks, because some of them are going on 30, maybe even close to 40 years old now, and they do encounter some issues, most of them mechanical in nature. We at the TV station, we've got, I think, around a dozen of these clocks. Actually, just this last week, another broadcaster gave us 8 of these clocks, and so I spent quite a few hours over the last week working on those clocks. Some of them had issues, and I figured out how to fix those issues. And so I'd like to explain to you, if you ever come across one of these, what kind of issues you may encounter. Some of them are common to the to both kinds of mechanisms, and some of them are specific to a mechanism. And yeah, why Leitch offered these clocks with 2 different mechanisms at the same time, I have no idea. Maybe one was cheaper than the other. The other weird thing is that the models with the more primitive mechanism, the single motor mechanism, they have an extra feature where they can be configured to function as a master clock rather than a slave clock. So when the clock's operating in master mode, you set the time manually, and then the time code jacks on the back become an output rather than an input, and you can connect other clocks to it, and that one clock will drive all the other clocks. The models with the single motor mechanism can function as a master clock. The models with the fancier 3-motor mechanism cannot. They are slave only. That's very weird to me. I'm not sure why Leitch did it that way. So I guess I'll talk about the fact that the clock on the left has not set itself correctly. It's off by several seconds. So the clocks with the 3-motor mechanisms know where the hands are on the clock. You'll notice when I applied power, the first thing it did was it sent all the hands up to the 12 o'clock position, top dead center. And it does that to learn where top dead center is for all the hands. If you were to look inside the mechanism, which we will do in this video, the hands are driven by, each hand is driven by its own gear, and each gear has a slot cut in it, and there's a photodiode, and infrared light shines through it, and the clock knows when a hand is at top dead center because it suddenly sees the infrared light because of the slot cut into the gear, which aligns with top dead center of the hand. So upon power on, the clock sends all the hands spinning until each one occurs top dead center, and then it knows where top dead center is, and so it knows where the hands are at all times. The clock on the left is dumb mechanically. It has no idea where the hands are. All it knows how to do is to step the second hand by pulsing the stepper motor a certain number of steps, and then the minute and hour hands all follow because they're all connected in a single gear train. Only the second hand is directly driven. But the clock does not know where the second hand or any of the hands are. Inside the clock on the left, and let me preface this by saying that in the first video I made of the CSD-5300, I accidentally gave a piece of misinformation, innocently so. I actually demonstrated this clock, and I said that it must be broken because when I plugged it in, it set itself to the completely wrong time. And I thought there must be something wrong with the servos or the top dead center protection or detection rather, or something. But the truth is, there's no detection at all. Clocks like the one on the left have a battery inside them, a coin cell battery, and from the factory, the clock knows where the hands are as long as that battery is working. That battery keeps part of the microcontroller alive, and so it remembers where the hands are when there's no power, because the positioning of the hands was set at the factory. But once that battery dies, which of course has happened in all of these clocks now, the microcontroller no longer knows where the hands are. So every time it gets powered on after it loses power, it assumes that the hands are at top dead center because that's where they were at the factory. But the hands could be anywhere. And so the clock will think it is displaying the right time when it's displaying a completely different time. So what you have to do is put a new battery in these clocks and then put the clock into a mode where it relearns where top dead center of the hands are, and then from there it will know where the hands are for the life of that battery. So to fix that, you put the clock into manual setting mode and you set the clock to 12 o'clock, top dead center for all three hands. And then once you have manually set the clock to that position, you hold the set button until the light on the bottom begins flashing, and then while continuing to hold the set button, you press and hold the counterclockwise button, and then the light will go out. Once the light goes out, let go of the set button and then let go of the counterclockwise button, and that teaches the clock that that is where top dead center for the three hands are. And from there, it will be able to set itself to the right time. Now, I performed this procedure on this clock right before this video. I put a new battery in it, taught it where top dead center was, and we were good to go. But something's obviously gone awry because it's about 5 seconds fast compared to the clock on the right. And it looks like the minute hand maybe is not lining up very well either. So I'm gonna have to do this relearning procedure and hope that maybe there was some stickiness in the mechanism or something, and hopefully that has cleared itself by now, and if I do the procedure again, it'll be right this time. That brings me to the second issue that these clocks have, and this goes for both types of mechanisms, is that the mechanism can seize up, it can get sticky. And when that happens, the clock will, both types of clocks will begin displaying the wrong time because the stepper motor will pulse, but it'll be jammed and the hand won't move with the pulses. And so this can happen to both types of these clocks. And the fix for that is, it's actually really easy, and I'll show it in this video in a bit. It's pretty easy to take the movements apart and lubricate them. On the single motor kind, because it is a very old-fashioned style clock movement, you actually, really, the fix isn't to lubricate them, it's to do the opposite. It's to clean out all the old lubricant. There's grease that dries up and stuff like that. I have found what works best is opening up the mechanism and just using alcohol to clean out all the oil and all the grease that was there from the factory, and just leave it dry. Don't put new lubricant, just leave it dry, reassemble the mechanism, and I've found to have quite a lot of success. The reason for that is because everything runs with such low torque that any kind of lubricant, except maybe the lightest kinds of oil that are specifically made for clock movements, any kind of lubrication introduces a slight amount of stickiness, a slight amount of resistance to the mechanism, And the stepper motor operates with such little torque that any stickiness will cause it to bind up and not be able to overcome it. So with this style of mechanism, in my opinion, best thing to do is just clean out all the lubricant and leave it dry. If you have special purpose clock oil, you can give that a shot if you want on the pivot points and where the shafts connect. Otherwise, just leave it dry. The mechanism for the 3-motor kinds of clocks is actually simpler. It's 3 motors that drive basically an improvised worm gear. It's actually a spring. Each motor drives a plastic shaft that has a metal spring wrapped around it. And that spring meshes with the teeth on the gears to drive the hands of the clock, 1 gear for each hand. And I have found the best way to lubricate this kind of mechanism is to, once again, clean out all the old lubricant, and then I apply lithium grease right to the spring, and I have found that to work really, really well. So that's a way that I have found to remedy sticky mechanisms. It can manifest if the clock is moving quickly, like if the single motor clocks are setting themselves, or if you're manually setting the 3-motor kind, which causes the hands to move fast. What you'll notice is that the hands can stutter, or you can hear the stepper motors go, but the hands don't move at all. One of these clocks, the previous broadcaster who gave them to us labeled one of these clocks as having a slipping second hand, as if the second hand was slipping, but otherwise the clock was fine. But what was actually the matter was that the entire mechanism was seized. It was this clock, I believe. So yeah, it's not a matter of slipping, it's that the mechanism is seized and the clock will not function properly. So that is what you can do to remedy these clocks. And so far, that's the only mechanical issue that I've observed with one of these. Next, I'll talk about really the only electronic issue that I've observed with these is that most of these clocks, I think the vast majority of them, based on my experience, have a backlight built into them. Leitch built a backlight into these, and after 30 years, most of these clocks, the backlight doesn't work anymore. There's 2 different types of backlights that Leitch used. One type they used up to 1992-93, and then the other type they used after 1993. The older type of backlight is electroluminescent. It all around the circumference of the face of the clock is an electroluminescent tape, and there's an inverter that powers it. And I have not seen a single one of these clocks yet with the electroluminescent backlight that works. Some of them I have seen have dead inverters, and some of them have what appears to be non-functional tape itself, like the EL tape develops a parasitic resistance or something, and it just puts too much of a load on the inverter and the voltage tanks, which may be what kills the inverter. Maybe all of these, it's the EL tape that goes bad, and eventually it kills the inverter, and that's why I've seen dead inverters on some of these. But yeah, I've yet to see a single one of these with the older EL backlight where the backlight actually works. The newer type of light that they began using around 1992-93 is a cold cathode fluorescent lamp. And I have seen a few of these clocks that have the CCFL lamp that do still work. One of them that I found was from 1995, and the other 2 were from 2000. So it seems that the more recently built of these clocks have CCFL backlights that are still working. And the CCFL backlight does not go around the circumference like the EL backlight does. It only goes across the top. And then the optical properties of the acrylic face transfers that light all the way around, and it looks very, very nice. I've got a pre-recorded clip here of 2 clocks that we got that have working CCFL backlights, and it's very pretty. I love how it looks. They glow a very ghostly white. It's not very bright. It's really pleasant when you're in a dim room, and I love it. And it's too bad that so few of these clocks seem to have a working backlight. And the failures, and most of the clocks I've seen with the CCFL backlight is dead, and what happens is the CCFL lamp fails. The inverter still works, but the lamp has failed. And I would think, and this is something I want to try, I would think since the CCFL ones, the lamp just stretches across the top here, I would think it would be very easy to convert those to an LED backlight using like LED tape. And so that's something I do want to try someday. I'm very interested to see if I could relight one of these clocks with LED tape. I just got to figure out where to tap 12 volts DC off of the power supply or the PCB inside the clocks. So that's the electronic issues that occur. So most Leitch clocks that you'll run across are or at least most of the ones that we've ever gotten a hold of are this type, the 12-inch size of clocks. But there are other types that Leitch made. There's bigger 16-inch ones and smaller ones that I think are 6-inch. So let me grab, I have one of each of those here. Let me grab them and show you what they look like. Well, here's a funny looking duo. On the left is a 16-inch clock, and on the right is a 6-inch clock that's designed to mount in a rack. You can see with these rack ears on it. All of the Leitch clocks are able to go in a rack. You can mount rack ears onto the 12 and 16-inch ones too. But the 6-inch one is specifically designed for use in a rack. And it's funny the difference in size. This isn't even the smallest Leitch clock. Leitch made an even smaller one, a 5-inch clock that was designed to just sit on a desk, which is kind of funny. Both of these clocks are the kind with the 3-motor movement. And I forgot to mention how you can know that before you even power them on is the clocks with the single motor movement have models starting with ADC, which means analog digital clock. And the clocks with 3 motor movements have model numbers starting with DAC, which means digital analog clock. I'm not kidding. I don't know why they did that. But anyway, this 6-inch clock has been in our storage for years. I've never actually bothered to test it before. This is the first time. I don't even know if it works. So pardon me, I'm going to step in front of you again and we'll turn these on. See what they do. There we go. And 29, 30, yep, they both seem to be reading the perfect time. So yeah, the little 6-inch guy works. I'm hearing quite a loud buzz from this guy. So it's got an electroluminescent backlight. When was this guy made? 1991. 1991 vintage, and I'm hearing quite the buzz, like a 800 or around 700, 800 hertz buzz coming from it, which is probably the electroluminescent inverter. I don't see a glow though, but just for kicks, I'll turn the lights off here. Wow, this is a first. I don't know that you'll be able to see it, but this little 6-inch clock has, it's glowing just barely. It's almost imperceptible, but I think you can just barely see that. This 6-inch clock has just the most, it's just barely glowing. So this is the first time I've seen one of these with a technically working electroluminescent backlight. It's obviously extremely worn out, but the fact that it's glowing at all, that's pretty cool. Well, there you go. This rack mount 6-inch clock is very cute. I think that I think I know where maybe we can use it at the station, mounted in a rack in our server room. We don't have any clock in there, so snake an audio cable from the CSD-5300 into that room and mount this clock in that rack. I think it would be very handy there. So that's the clocks, but let's look inside them. I'll show you what they look like inside, and we'll even open up the mechanisms too so you can see what they look like. We'll start with this clock. This is a single motor 12-inch clock. It's the model ADC-5100-L. The L meaning that this has a backlight, or it did. It was no good, obviously, and so I removed it. This is the one that I'm going to try and convert to LED, see how feasible that is. It was made in 1994, 94 first 2 digits of the serial number, and of course all these clocks, at least all the ones sold here in Canada, were made in Canada. Leitch was a crowning jewel of our manufacturing industry. So, to get inside this thing, we're going to take out all the screws that are on the outside, and then the entire back panel will come away. Well, I finally had to go handheld after however long this video has been going, but here is the clock opened up. You can see the stepper motor and the little red error LED are tethered to the back through this little plug, so I'm just going to pull that out. So that plug plugs in right there on connector P2 on the leftmost pins with the yellow wires facing up, just like that. And now we've got the back of the unit. So you can see we got a transformer, linear power supply, we've got a fuse, there's the microcontroller, a Motorola MC68HC705, so either a, well, definitely not a 68,000, must be a 6800 based microcontroller. That's pretty cool. And there's a little coin cell battery that the clock relies on to know where the hands are. I also read in the manual that if the, because of this, thanks to this, if the clock loses power and time code is not present when power returns, the battery actually keeps track of the time itself as well, so it'll still be able to set itself to the correct time until time code is restored. That's pretty cool. So yeah, that's the board. You can see where AC power comes in. This connector feeds the time code connector, the spring clips on the back here. And so how you put these clocks, only the ADC clocks can go into master mode and output time code for other clocks to run off of. So how you convert one of these to master mode is you remove this connector labeled P1 and you flip it around and plug it back in, and now it's in master mode, and this is an output instead of an input. So that's how you do it. And there's a variable capacitor there. That's a little potentiometer there. I'm not sure if that would adjust the internal oscillator or not. It's kind of cool that that these can run on either an internal oscillator or line frequency as the clock base. You can see the third dip switch down there. You can choose either the quartz oscillator or the line. I wonder which is more accurate. I grew up with the understanding that line frequency, like AC powered clocks, are the most accurate clocks you can get, because the mains power frequency is so tightly regulated to the point where I read once, and maybe this is an old wives' tale, but I read once that when if like every day at the end of the day, the power company basically has a count of how many cycles came through the power line, and if it was just slightly fast or slightly slow of 60 hertz, they would actually adjust it very slightly for the next day to bring it back in line, with the purpose of this being that any AC powered clocks would remain on the correct time. They wouldn't go fast or slow. I wonder if that's true. Oh, you've got 5 and 12 volt regulators. Okay, that answers my question as to how, if I could tap power off of this for an LED backlight, which is cool. Speaking of the backlight, this originally had the CCFL backlight. The inverter originally mounted right here, and I have the inverter. This is what the inverter looks like. It was made by TDK, who made a lot of CCFL inverters. Model BXA2405, made in Japan. And its little power lead connected, I believe, yes, it connected right here. So if you're ever working on one of these with the CCFL backlight, the backlight inverter plugs in right here on the rightmost 6 pins, and I remember the positive wire is left of the negative wire. So that's how the inverter plugs in. And then the green and the blue wires plugged into the CCFL lamp. So yeah, I've got to find out. I'm going to just try a strip of LED tape up there and see how well it works. That would be pretty cool if that's a way of relighting these clocks with the failed CCFL backlight. So that's the circuitry. Now on to the mechanical bits. So here's the movement. And the actual clock movement is this brass colored part. And so far I have not seen one of these need lubrication or old lubrication cleaned up or anything. So I probably did a bad job. I probably should have distinguished that at the beginning when I was talking about lubricating and getting these mechanisms moving. But on this type, it's not actually the clock movement that's the issue. It's actually the gear reduction of the stepper motor. So here's the stepper motor, and then it goes into a gear reduction. Old-fashioned AC powered clocks that have a synchronous motor, they work the same way. This would be a synchronous motor going into a gear reduction and then the clock movement. What Leitch did was just take that entire assembly and replace the synchronous motor with a stepper motor that can run off low voltage DC. And it's this gear reduction that actually becomes an issue, where when the motor and gear reduction is removed from the clock movement running freely without the resistance of the clock movement, I still observe these stutter because the gear reduction itself was placing too much of a load on the motor, just because of dried up grease and stuff. So what you do is these two screws right here come out, and then the motor and gear reduction assembly just pulls straight out. So you take those screws out, stepper motor pulls off just like that. And it's a little hard to do, but this cover comes off of the gear reduction. And the cover is held in by these tiny little tabs that have been cut out of the rim of the housing and folded over. And I found what I had to do was just take a couple of flathead screwdrivers and basically pry the housing outwards so that this cover could come off. And there's a hole cut in the cover so it comes off around the little output gear here. And what you'll find inside is the gear train, which once again you can just pull straight out. And it just, when it's in there, it just meshes with the output gear of the motor itself. And none of this is timed. None of this has any special timing, you know. You're not going to hurt anything if you fiddle with the gears or anything like that. So you're free to just pull that gear train out and then you can clean the old grease off it. Regretfully, I didn't take a photograph when I had one of these apart, and I don't want to pull another one apart because it's hard to do. It's hard to get this cover off. It's also hard to get it back in and get it centered around the output shaft and stuff like that. But it's doable. You don't need to be an expert to work on one of these. And then it just meshes back in, and put the 2 screws back in and you're good to go. And if you need to remove the face of the clock to realign the hands so that they land on the markers, which I actually do need to do with this clock, because as you can see, both the second hand and the minute hand are not quite aligned. Something that the average Joe would never be bothered by, but I find it kind of annoying. But what you do is you remove these 4 rather, nuts, and then the entire face of the clock comes out. So that's how that works. So that's the inside of the ADC-series clocks with its single motor mechanism. Let's pull apart one of the DAC-series clocks and take a look inside them. Getting inside the DAC clocks is the same as the ADC clocks. You remove the screws all around the outside, and you can see inside it looks quite a bit different. You can see the 3 stepper motors that drive each of the hands. And kind of interesting, this clock has been repaired in the past. 2 of the stepper motors have 1991 date codes, and this one has a 1998 date code. So when this clock was 7 years old, one of the stepper motors failed, and it was repaired presumably by Leitch. So aside from the movement, you can see other differences here. This clock has an electroluminescent backlight. So there's this electroluminescent tape that goes all the way around the face of the clock. You can see the adhesive has failed right here. And you can see that power is provided to the EL tape in 2 different points. And actually in the bigger 16-inch clocks, it's done at like 6 or 7 different points. They're all parallel together. It's just to reduce the voltage needed for the inverter to output. If it was all one series string, it would be very, very dim or not light up at all. So because of the different backlight, the optical properties of the face to properly distribute the light to, around the face of the clock has to be different. So clocks with the CCFL backlight have quite a thick sheet of acrylic in front of the face of the clock, where this just has quite a thin sheet of plastic. And instead the body of the face of the clock is acrylic and is quite thick so that the light can propagate all the way around. And so because of that, the way the face of the clock is mounted to the case is different as well. We've got these acrylic bars which were originally glued to the back of the face, but that glue has failed on most or all of these. I find double-sided tape, just the cheap Scotch stuff with the green tartan backing. I find that stuff works pretty well to stick these back on. You just got to be careful to make sure the face lines up and isn't crooked. And interesting, you can see the backing of the face on this clock has developed these cracks in it. I did work on this clock in 2020. I believe I probably did take the face out, and I wonder if I perhaps screwed it back down too tightly, and these acrylic bars are pressing down on the edges but not the middle, and so this backing diffuser material stretched, and maybe that's what caused these cracks. Or maybe they were always there. I don't remember. Here's the circuit board, different than on the ADC clocks, of course. The electronics are very different, at least the digital side of things, because now it's driving 3 hands instead of just one. We do have a frequency adjustment right there, so although the DAC clocks, oddly, can't operate in master mode, they are purely only slave clocks, you can adjust the frequency. So if they're not receiving a timecode signal and they're running off their own oscillator, you can tune them to stay very, very accurate. So if you were to get one of these and use it without a timecode source, just in your home or whatever, you could still tune these to be the most accurate clock in your house aside from your computer or cell phone. And that little brick right there is the CCFL, or the electroluminescent rather, inverter. It's made by a company called ERG. It's called the Smart Force Inverter. And this one's actually got a different model. I guess the 16-inch ones must have a different inverter that's more powerful. This has a different model number. But yeah, there's not really, these aren't made anymore, these inverters. I don't know if there's a new equivalent, but there's nothing made under the same model number anymore. So I would also be interested to see how easily these electroluminescent faces could be converted to LED. If it's as simple as just stringing some LED tape around the circumference, or would it be too bright because the LEDs are obviously going to be a lot brighter than the original electroluminescent? Don't know. Both the ADC and the DAC clocks have a trimmer on them called hum null. That's kind of interesting. I wonder what source of hum you are nulling. Is it like line frequency hum from the transformer somehow, or is it hum from the stepper motors? I don't know. But both types of clocks have that. And yeah, we've got, what have we got for major semiconductors? I believe that's National Semiconductor, NSC 810 and NSC 800. So I don't know what those are, but I'll probably have something on the screen. And yeah, the electronics connect to the motors with this big ribbon cable, much different than in the ADC clocks with its little 6-wire connector. And the EL backlight connects to this little board that ultimately goes down this ribbon cable. So 2 of the wires in this ribbon cable are the high voltage coming out of the electroluminescent inverter. So yeah, we'll take a look inside the movement. So much easier than in the ADC clocks. You just take out these 2 screws and this plate lifts off. So we'll do that and take a look inside. Here's inside the movement. Much simpler than in the ADC clocks. You've just got 3 gears back there, 1 for each hand. And the 3 stepper motors are each driving a what appears to be nylon shaft that has a metal spring wound around it. And indeed, I was in here in 2020. I can see some, at least I think I see some lithium grease. No, that doesn't feel like lithium grease at all, actually. So yeah, maybe. Yeah, I was in here in 2020, and I did the same thing that I've done in recent weeks with the clocks we just received. So at least I'm consistent. Don't know if I'm right, but I'm consistent at least. And yeah, what I have done and have been doing is cleaning up these springs, which are basically makeshift worm gears, with alcohol, and then coating them with lithium grease, and that seems to do the trick for freeing up these mechanisms. And yeah, that's as far apart as you have to take one of these. Actually, I probably didn't even get the shaft in behind there. So whatever that might be, that's probably the hour hand. I've actually never lubricated that, and on none of these clocks have I had to do that yet. So there you go. That is the inside of both kinds of mechanisms that you'll see in these clocks, as well as what the electronics look like. And the two different kinds of backlights you'll find as well. So there you go. Well, I didn't think I would actually do it, and even successfully do it, before airtime for this video, but I did. This clock, which is one we just looked at the inside of, has been modified with an LED backlight. And that looks terrific. That looks exactly like what the original CCFL backlight would have been. This is the ADC-5100 clock we looked inside of first, which had the CCFL backlight. And honestly, with those LEDs in there, it looks largely the same. It's very impressive, and it just looks, subjectively, it just looks terrific. So let's go back inside this clock. I will show you what I did and how. So I took a section of this LED tape. I took a section about that long from the end of it there to where my thumb is, so about, what is that, 7-8 inches or something, and I cut that off, and I pinched it underneath of the plastic shield where the original CCFL tube was, right across the top of the clock, and I positioned it with the diodes facing down, so shining light directly onto the piece of acrylic, this piece of acrylic that carries the light across the face of the clock. And then I actually soldered onto this piece of tape the original wiring harness from the CCFL inverter, which originally lived right here and plugged into the board right here. I was able to reuse that and even reuse the same 6 pins on the board to power the CCFL, but I had to turn the connector around. Let me show you the board again. So this 6-pin connector connects to the 6 pins on the right hand side of this big connector here. Now, the original CCFL inverter runs on 30 volts DC. This LED tape runs on 12 volts DC. And it just so happens that the way these 6 pins are arranged, the 2 pins in the middle are ground, the 2 on the left are 30 volts DC, and the 2 on the right are 12 volts DC. So where the connector was originally positioned with the red wire on the left to connect with the 30 volt DC pins, I just flipped it around so that the red is on the right, and it now connects with the 12 volt DC pins. And as you saw, it lights up that LED strip, and that LED strip does a tremendous job of emulating the old CCFL tube. The color is slightly warmer because this particular LED strip is cool white LEDs, but if you're able to get something like this with 5000 Kelvin LEDs, and if you can get something that has like a diffuser, a flexible diffuser over it rather than the bare diodes being soldered on here, it would be an even better emulation. But yeah, I can't believe how well that turned out. I might hang this clock up here. I'll find a place here to do it. Maybe I'll replace my neon clock there, or maybe I'll stick it like up there or up there. But yeah, I'm so surprised how well this turned out, and I like how it looks so much. I think I'll hang it up here. Might as well give the CSD-5300 something to drive. So now my next project someday will be seeing if a similar LED tape can work on the clocks with the electroluminescent backlight. My prediction is that it will work, but perhaps it'll be way too bright, in which case I'll just have to find a suitable resistor perhaps to string across the LEDs to limit the current, because I'm sure that the EL tape it originally had would have been very dim compared to what these LEDs will do. But that's something I will find out another day. But yeah, at least with the CCFL clocks, it's very easy and works super well to convert them to LED. And that's the update on the Leitch CSD-5300 and some new information that we've learned since the original video 1 year ago. I've been so happy to see the reception to this thing ever since I hooked it up to a telephone line and made the phone numbers public. It's been really cool to see all the calls that have come into this and what people are doing or trying to do with this thing when they call it. And it was also really cool to get the email from the person who works at the BBC and manages one of these. His information on how to tune the oscillator to make these super accurate, like they would have been out of the factory. Really great to know, and I'm glad to share that information as well. And I've learned a lot of stuff about the Leitch slave clocks since the original video, how to fix some issues that I've seen crop up in them, and so I'm glad to have been able to share that information as well. I think this is the first YouTube video about any of this stuff, this and the original video I made. So thank you very much for watching. I do hope you enjoyed. I hope you were and are intrigued by this thing and the stuff that it does. And we've gotten a lot of slave clocks that other broadcasters have retired. I hope someday we get some more of these as well. We've just got the two, this one and the one at the TV station. And if the one at the TV station ever dies, this one's got to go, and it's got to go to the TV station. I hope that never happens. These do seem to be extremely reliable aside from the power supply capacitors, which I've taken care of on both of these. But I hope we get more of these someday so we can have a spare, and if we get enough, I've had at least a couple of people express interest in buying something like this if we ever come across any spare ones. So that would be cool. So thank you very much for watching. I do hope you enjoyed, and thank you to my Patreon supporters as well. Before I go, I want to give a little personal note to my American viewers. Consider supporting your local public broadcaster. They need it right now more than ever. Have a good week.